Our group number is number 54, and our project title is Finetune BERT for classification tasks. So let's look at our project libraries and packages. First, we used transformers, and then NumPy, pandas for the mathematical operations. Then we use PyTorch for neural networks. Then for the plotting operations, we use Seaborn and Matplotlib. Then we used scikit-learn for split the dataset split the dataset. Then we used auto model for the loading purpose of the model, and then BERT tokenizer fast for tokenization.
Then we load the our dataset from CSV file for training and evaluation. Um, this is our dataset shape. Um, then we check class classification, and then we in this section we split the dataset into training, validation, and test sets for model training and evaluation. Uh, then we import our base model as BERT and BERT tokenizer. Here load our then we tokenize our datasets. Um, in here, this block tokenizing our in this section we tokenize our training datasets, validation datasets, and test datasets. Um, Next, we convert integer sequences to tensors using Python.
Okay, next we'll create the data loaders, and we will have a batch size of 32. Then we define the data loaders, and then we are going to freeze the parameters of the base model, and we are going to change the architecture. So in this part, we have at the dropout layer, an activation layer, and two dense layers, and last we have at the soft map activation layer.
Then we use the Adam optimizer as our optimization function during the back propagation. So we use 10 to the power minus 3 learning rate for the back propagation for the optimizer. And there is a class imbalance. So we use NLL loss for uh, reduce the class imbalance. So you can see the code for that part is over here. So next we have to fine tune. For that we created two main functions, one for our training and other one for the evaluation part. So during the training we set the model for in the training mode, and then we go to the our database. The initial database size is 32 per batch. So we set the model parameters to 0. Then we get the predictions from the model and we calculate the loss from the model using the cost entropy. So we also take the total loss, so we can identify the model performance, and then we do the back propagation, and then we update the parameters using our optimizer that we have used. So that's the all happening inside the training loop. So during the evaluation, we get the model to the evaluation mode, and we do the predictions on the our evaluation data set. So you can see. So during the evaluation, we don't have to train the parameters, so we check the model for no gradients updates. Then we do the evaluations and finally get the loss in to our evaluation data set, to our validation data set. That's the two functions. Next, we have to start the training. For the training, is the training process localized? We have created a function for that. So initially, our training was done for 10 epochs. You can see the loss is gradually decreasing. Also, the training loss and validation loss are gradually decreasing, and also we are saving the model. the best model will be saved using the validation phase. So finally, we can load our saved model using this code, and then we can do predictions. Before predictions, we check how the model performance looks like. Here's the confusion matrix. So here we can see positives are negatives are identified correctly, almost correctly, and also the positives are identified as positive. So this is good performance. Next, we created a one function to predict to use our model on unseen data. Here's that function. So we use one sample data control relationship on a free icon like that. So if the model is performing this as a span, and model is performing text like how, hey, how are you doing today? It's answer, not span. So our language model is trained, fine-tuned correctly, we can see from our final predictions. So that's our project. Thank you.